Hello friends, myself R.D. Mahajan presenting my video on contour integral. Let us evaluate contour integration of 2z square plus z whole divided by z minus 1 into z plus 1 and its integration with respect to z or closed curve C, and that curve C is here mod of z is equals to 1. Standard circle, center at origin, radius 1. And therefore, to obtain its value, f of z is equals to 2z square plus z is an analytic function. To determine the pole, we equate these denominator terms to 0. We get z minus 1 equals to 0 and z plus 1 equals to 0. It gives you z is equals to 1 and z is equals to minus 1. These are two simple poles. And then we determine whether it lies inside or on or outside the curve. Therefore, mod of z at z is equals to 1, it becomes mod of 1, value is 1, which is equals to that radius 1, and therefore point lies on the curve. Point lies on curve C. Then we determine for second value mod of z, it is mod of minus 1, absolute value of minus 1 is 1, and again that is equals to this radius 1. Therefore this point also lies on C. And as both point lies on C, by Cauchy's formula, we had to determine two different values for that integral. Suppose the first one is I1, keeping one term in the denominator only and shifting other term with the numerator term. Therefore, contour integration of 2z square plus z divided by that z minus 1 and whole divided by z plus 1 and its integration with respect to z. Its value is 2 pi I into f of z at z is equals to minus 1, and therefore that f of z is here 2z square plus z whole divided by z minus 1 at z is equals to minus 1. And therefore if we try to evaluate that value, we get 2 pi I multiplied by, put z is equals to minus 1, minus 1 square is 1, therefore 2 into 1 we get 2, plus z, z is minus 1, and whole divided by minus 1 we get minus 2, and therefore that value is 2 to get cancelled, we get this one as 1 upon minus 1 means minus, therefore that value is minus pi I. This is the value of the first integral I1. Then we determine the second value for the integral as I2. Suppose it is nothing but contour integration of 2z square plus z divided by z plus 1 and whole divided by z minus 1, and as per that Cauchy's integral formula, its value is 2 pi I into f of z, that is 2z square plus z whole divided by z plus 1 at z is equals to 1, and therefore substituting z is equals to 1, we get that value as 2 pi I. 1 square is 1, 2 plus 1 we get 3, and 1 plus 1 we get 2. Therefore that value is, to get cancelled, we get that value as 3 pi I as the value of I2. Then we take the addition of I1 and I2 to get the value of this contour integral. Therefore, finally we get the value of that contour integral as sum of I1 and I2. The value of I1 we have minus pi I. Value for I2 we get as 3 pi I, and therefore addition of these two terms is 2 pi I as the final value of that contour integral, or this is the required answer of that contour integral obtained by applying Cauchy's integral formula. One more problem I will discuss in my next video. Therefore, if you like my video, please share it as well as subscribe to my channel to receive the notification for my new videos. For that, you have to press the bell icon. Thank you. Thanks for watching.